Okay, let's start again. Now let's do further few questions. You start y equal, you take this one, y equal 1 over x into x minus 1. You try to do it. One by one, you follow the steps. Find x-intercept, y-intercept, find vertical asymptote, horizontal asymptote, and differentiate, find critical point. Okay, start it now. Okay, now denominator zeros, x equal 0, x equal 1, we call vertical asymptote. Vertical asymptote. You better to check tendencies. Check this one, x goes to 0 plus, x goes to 0 minus, x goes to 1 plus, x goes to 1 minus. Check tendency of y. Then all y values goes to infinity. But we need to check whether it is positive or negative. Okay. 1 plus mean take 1.1, substitute here 1.1, here positive, here 1.1 positive, all values positive, then positive. 1 minus mean take value less than 1, 0.9. So close value, 0.9. Then here 0.9 minus 1, negative, positive, positive. Then result negative. Then 0 plus mean 0.1. Take 0.1, positive, positive, negative. Then result negative. 0 minus mean minus 0.1, negative, negative, positive, then fully positive. Then all denominator zeros, the corresponding y tendency always infinity. Then you need to check whether it is positive or negative infinity. Positive or negative infinity, okay? Then 0 plus mean you select value greater than 0, close to 0. That's why I take 0.1. 0 minus mean you take value less than 0, close to 0. That's why I took minus 0.1. Here minus 0.1. Then 1 plus mean take 1.1, 1 minus mean 0.9. You substitute original function and check only the sign. Check only the sign. Then 1.1 plus mean 1.1 substitutes, see the sign and put that sign here. 1 minus mean take 0.9, substitute here and get the sign, and negative you put here. That is horizontal asymptote. Sorry, vertical asymptote. Then horizontal asymptote. Horizontal asymptote, it is proper now. Then as x goes to plus or minus infinity, y goes to 0 for proper rational function. This is called horizontal asymptote. horizontal asymptote. Now here, when you substitute x0, it is undefined. When you substitute x0, it is undefined, no x-intercept and no y-intercept. When x0, y undefined. Therefore, no y-intercept. No y-intercept. When y equals 0, 1 over x into x minus 1, 0, then no x value for this. Therefore, no x-intercept. Then we don't have any intercepts here. So if we substitute x equals 0, if we get any real value, that will be y-intercept. When we substitute y0, if we get real value for x, that will be x-intercept. But in this case, we don't get any intercepts. Then y equal 1 over x into x minus 1, now you differentiate. X into x minus 1 square, denominator is square, denominator times derivative of numerator minus numerator times derivative of denominator. Here we have product now. X derivative 1 into x minus 1, x minus 1, x into x minus 1 derivative 1. Here the derivative. Now you simplify and get it. Here 2x minus 1, minus 2x minus 1, here minus outside, 2x minus 1, over x into x minus 1 squared. Here dy by dx. Dy by dx. Then go further. Take time. Okay, then you check dy over dx, 0 case. To find critical values, solve dy over dx 0. That is minus 2x minus 1 over x into x minus 1 squared. Then x equal half is the solution. Here critical value. X equal half critical value. Then you have to identify critical point. Then corresponding y value obtain. 1 over put half. Half minus 1. Then we get minus 4. Then half comma minus 4 is the critical point. Now you have to check sign. Now see this sun alpha. So when you get in sign, check this up. You have to think about critical value. And as well as denominator zeros, because our derivative is this now. So derivative 2x minus 1, x into x minus 1. No? Therefore, here 0 half, and here zeros 0 and 1. Then critical values now, just special values. Here 0, 1, and they are half. Here the value. Now get the ranges here. Less than 0, then 0 to half, half to 1, greater than 1. Here the ranges now. Okay, you have to think about critical value and as well as denominator zeros both. That is important. That is important. Okay, now dy over dx, here we see denominator power 2 even. Then surely this part positive. Surely this part positive. And outside we have minus, negative. Then completely here only this part negative. Then 2x minus 1 sign change only at half, no? So half here, then about this sign will change. X squared, x minus 1 squared, then no sign change. Then x equals half, only sign change. Then about this only sign change. Then usually greater than half, this part positive, but outside we have negative. Then greater than half, we get negative now. Then here change the sign. Then no change sign, no sign change here. Okay, do up to that, do up to that. Don't go further, do up to that. So we have to analyze this one further clearly. Okay, now see this one. Now see. Now only critical point half minus 4, then half mean here plus to minus variation take maximum. Clearly identify this. Here only critical point half minus 4, then plus to minus variation we call maximum. 0 and 1, 0 and 1, we got that they are vertical asymptote. See this one clearly. 0, 1 vertical asymptote. Therefore here positive touch. Here positive touch like this. Here right side again positive touch like this. Don't get here inflection, okay? Inflection happen with critical point, but here not critical. Critical value we have only 1. Then plus to minus variation maximum. Here positive touch. Here positive touch, acute angle touch. Then here negative, negative in obtuse. Then here negative touch, negative touch. Then here asymptotes, asymptote. Then those asymptote we have analyzed by this. Here same thing we have analyzed. Then you can remove this one, you can go with this sign of dy over dx now. You can forget this part now. But anyway, you have to split this table with denominator zeros as well in dy over dx. Now you have identified that. Now you know vertical asymptote, horizontal asymptote, and xy intercept, and critical points, we know all the things. Then we can sketch, no? Then we can sketch. Now let's sketch. See this on all. Here x-axis, y-axis. First go to asymptotes. Here we have two asymptotes, 1 and 0. Mark them. Here 0, here 1. Okay. Then the other one is y-axis. Now go to critical point, half minus 4. Here half minus 4. Here the point. Then half minus 4 maximum. 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 Okay. Now check when x goes to 1, left side minus infinity. Then you touch it here. Then x goes to 0, 0 plus side minus infinity. You touch it again. Touch the axis. Then 0 plus minus side, 0 minus side plus infinity. Touch. And 1 plus side plus infinity. Touch it. Now go to horizontal asymptote. X goes to plus or minus infinity, y goes to 0. Y goes 0. Then as x goes to minus infinity, y goes to 0. Touch this axis. X goes to plus infinity, again y goes to 0. Touch it. Okay. Here 0. Complete graph. Then you have to label critical points, and you have to label vertical asymptotes, you have to label horizontal asymptote. If there are x-intercept, y-intercept, you have to label them. You have to mark them, okay? Then only we can get full mark. Complete. Okay, now you check this one. Don't mislead this. Huh? Here plus to plus. Plus to plus variation, last week I told you, plus to plus variation I told this way, plus 0 minus, no? That for critical point, but here not critical point, 0 not a critical point, only half is the critical point. Then plus to minus maximum, then here plus to plus you can't sketch this way. Here vertical asymptote, that's why here positive mean gradient, positive mean acute angle touch. Here acute angle. Then you curve it. Then here again right side positive, then acute angle touch, curve it. It goes like this. Then here negative, obtuse angle touch. Here obtuse angle, both side negative, negative, negative and negative. No? Don't mislead with the other previous case. Huh? So that happened for critical values. These are not critical, they are asymptotes. Only critical point here it is, plus to minus variation. Okay. Now let's do another one. Okay, you try this. Y equal x over x minus 1, x minus 2. Y equal x over x minus 1, x minus 2. Okay, try it. Okay, now if you have any doubt, do with me. Now let's find intercept. When x0, y value 0. Here y-intercept. When y0, x0, here x0, we call x-intercept. Now denominator zeros, vertical asymptote. Let's find asymptote. Asymptote, vertical. Denominator zeros 1 and 2. Then you have to check x1 plus x1 minus y change, y variation. Then x goes to 2 plus 2 minus y variation. Then all y tends to infinity. Then 2 plus mean 2.1, positive, positive, positive. 2 minus mean 1.9, positive, negative, positive, then negative. 1 plus 1.1, positive, negative, positive. 1 minus, negative, negative, positive. Then here proper rational function. Proper rational function. X goes to plus or minus infinity, y tendency to 0. Here horizontal asymptote. Horizontal asymptote. Okay. Now got differentiation procedure to obtain critical points. Here differentiate with respect to x. Then dy by dx, x minus 1, x minus 2 square, denominator is square, denominator times derivative of numerator minus numerator times derivative of denominator. Simplify. Here x square minus 3x plus 2. Here 2x square minus plus 3x. Cancel 3x. Here x square minus x square plus 2. X minus 1, x minus 2 square. Then factorize numerator. X minus root 2, x plus root 2. These are irrational values. Do up to that. The procedure you follow: find x-intercept, y-intercept, find horizontal asymptote, vertical asymptote, find critical points. Find critical point. When finding critical point, we have to sub procedures. Differentiate, get derivative, factorize and equate that to 0, find critical values, then substitute the function, then get critical point, then check dy over dx sign, then identify the critical point. That is the way of finding critical point. Okay. So there are big steps here: intercept, asymptote, critical points. So each step you have sub steps. Then you do one by one. Do up to that. Okay. Now dy over dx equals 0 case. To find critical values, solve dy over dx 0 minus x minus root 2 x plus root 2 x minus 1 x minus 2 squared. Now we have two critical values, x equal minus root 2, x equal plus root 2. Here critical values. Then you find corresponding y value. You find corresponding y value. Here substitute plus root 2 and minus root 2. Substitute plus root 2 and minus root 2. Then minus root 2 minus root 2 minus 2. Then here simplification somewhat hard. Plus root 2 now see the values, see the values. Now here this case, here fully negative, 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 positive, negative divided by positive, we get negative value. Then here minus root 2 divided by, here root 2 plus 1, root 2 plus 2. We can rationalize and we can check, but here we can easily say positive value, negative value here. Now check this. Here root 2 minus 1 positive, and here negative, and here positive. Then here this value negative, no? Here this is positive. Again negative, no? Negative. Then here better to simplify, otherwise both negative, no? Then let's expand it. Here 2 plus 4, 2 root 2, 3 root 2. Okay, na? 2, 2, here plus 2 root 2, 1 root 2, hurry. Then root 2 divided by 4 plus 3 root 2. Then here root 2, 2 plus 2 minus 3 root 2. 4 minus 3 root 2. Okay. So if you get this one A, if you get this one B, here we can say A value less than B. A value greater than B. Here this fraction small, no? Here this fraction is small. Here this fraction somewhat big. Therefore, numerical value big. Here therefore A value less than B. Do up to that. Do up to that. To rationalize. These are the values. These are the values. Now check dy over dx sine. You have to get critical values, minus root 2 plus root 2, and denominator zeros 1 and 2. Then smaller value minus root 2, then 1, then root 2, then 2. Here are the ranges. Those are the ranges. Now we're going to find sine of dy over dx now. Here dy over dx. Now check this analysis. Here dy over dx. Then denominator purpose common, no sign change here. So we have linear factors. Then sign change at root 2 and minus root 2 both. Then sign change only here, minus root 2 and plus root 2. Here minus root 2, that must be extended, no? Minus root 2, 1, 1, then root 2, root 2, then 2. So sign change at plus root 2 and minus root 2. Here only sign change, plus root 2 minus root 2. Now linear factor product always right hand corner one plus, minus, plus. But here outside minus, then reverse the sign, minus, plus, minus. Then here right side minus, then plus change, no change. Then again change, minus. Then here critical value, these two critical values, then minus to plus minimum, plus to minus maximum, here these two vertical asymptote, then positive touch, negative touch, negative touch. Okay, do up to that. Now sketch. Here x-axis, y-axis, minus root 2 somewhere here. Then 1 vertical asymptote, then root 2 somewhere here. Then 2 vertical asymptote. Then critical points here for minus root 2, for minus root 3 over 2. Here this is negative value, some small negative value here, somewhere here, minimum. Then for root 2, greater negative value here, maximum. Then one minus side, positive touch. When x0, y0, it passing through the origin, and minimum here, and touch x equal 1. Then x goes to minus infinity, it tendency towards 0. Then horizontal touch here at 0. Then here vertical touch. Then here vertical touch, horizontal touch. That's the graph. Complete. Okay, then you try this one. Y equal to x card of x comma minus 1. Here denominator factors not completely given. You have to find. You have to find. Continue now. Do alone. Intercepts. When x0, y value is 0, here y intercept. When y0, x value is 0, here x intercepts. Then asymptotes. Here factorize. We have two asymptote, horizontal and vertical. Then x equal -1, x equal +1. Vertical asymptote. Then check tendency. 1 plus, 1 minus, y. They are infinities. X goes to -1 plus, -1 minus, here infinities. So definitely you have to factorize the expression denominator to check vertical asymptote. Then 1 plus 1.1, positive, positive, positive. 1 minus 0.9, positive, positive, negative. -1 minus 1, minus 1.1, negative, negative, positive. Then -1 plus minus 0.9, positive, negative, positive, positive. Then here proper rational function, improper. Then take x square outside and simplify. Then we know as x goes to plus or minus infinity, y tendency leading coefficient ratio 2/1. It is 2, no? Then leading coefficient here 2, here 1, 2/1. Here y equal to horizontal asymptote. Horizontal asymptote. Okay. Then to find critical point, differentiate. Then dy by dx, start differentiating this. X square minus 1 is square, denominator is square. Denominator times derivative of numerator. Numerator times derivative of denominator. Then factorize this. Here 4x common take outside. X square minus 1 minus x square minus 4x, x minus 1, x plus 1 square. Then to find critical values, you get dy by dx to 0. Then we get x equals 0. Here one critical value. Then corresponding y value, we got that, no? 0. Then 0, 0, critical point. 0, 0, critical point. Do up to that. Okay. Then check dy over dx sign. Then denominator 0, minus 1, critical value 0, denominator 0, 1. Then check the sign. Here go to this. Here positive, here negative, here x positive. Then positive region, x greater than 0 positive, outside minus negative. Greater than 0 negative, less than 0 positive. Then plus to minus maximum, minus to minus, here obtuse angle touch. Here it is. Zero, 0 maximum. Here 1 minus 1. Here horizontal asymptote 2, no? Horizontal asymptote 2. Here 2. Then here plus touch 0, 0. Complete. Okay, that is about rational function sketching. Now you have capacity to do past paper questions, but anyway, next week also we need to do this practice. Then anyway, you try. I gave a tute, no? So in that tute, you try rational type function sketching. And past paper also you can start. Past paper also you can start and try to do it. But anyway, next week we discuss and we can complete differentiation part. හරි විනාඩියක් අහගන්න නම් මේ ඔයාලට මේ සතියේ පේපර් එක තියෙනවා නිවාඩු දවසක් තියෙනවානේ ඒ වුණාට පේපර් එක තියෙනවා මේ අපි ඒක උදේ තියමු උදේ පේපර් එක තියමු මේ ඔයාලගේ සීනියර් කට්ටියටත් පේපර් එකක් තියෙනවා එයාලටත් උදේ තියෙනවා ඔයාලගේ එක පේපර් එක තියලා 11ට මම 11 පැය 3යි 10න්නේ 8:00 ඉඳලා 11:40 වෙනකම් මම පේපර් එක දෙන්න. හරිද? සිල් ගන්න එහෙම කවුරු හරි හිටියද නැන්නේ? හරි මේ මොකද මේ ටර්ම් ටෙස්ට් එක එනවා ළඟ ටර්ම් ටෙස්ට් එක එනවා. ඒ හින්දා ඒ වෙනකොට ඔයාලට මේ සැරේ එක ගොඩක් කන්ටෙන්ට් වැඩි. ඒ හින්දා මේ සතියේ ඇප්ලයිඩ් පේපර් එකක් තියෙනවා. ඒ ඇප්ලයිඩ් පේපර් එක කරලා මම ඒ වැඩේ මේ සතියේත් කරන්න. හරි ඔයාලා මේ කරපුවා ආපහු සැරයක් බලන්න. ඩිෆරන්ෂියේෂන් ග්‍රාෆ් වල රැෂනල් ටයිප් ටික තමයි හැම වෙලේම එන්නේ. ඉස්සෙල්ලාම මේ ටික හරියට ප්‍රැක්ටිස් කරන්න. හරිද? අපි මේ කරපු ටික හරියට ප්‍රැක්ටිස් කරන්න. ඊට පස්සේ වෙනස් ගණන් try කරන්න. හැබැයි පුළුවන් නම් හොඳයි answers තියෙන questions කරන එක. ඒතර answers තියෙන question විදිහට ඔයාලට pass paper එක තියෙනවනේ හැම වෙලේම. ඉන්න pass paper එක කරන්න ඉස්සෙල්ලාම. හැබැයි ඕකේ ගිය අවුරුද්දේ ඊට කලින් අවුරුද්දේ තියෙන ගණන් දෙක විතරක් මම ඔයාලට දීලා තියෙනවා. pass paper set එකේ ඒක වැඩිය touch කරන්න එපා. ඊට කලින් ඒවා ටික කරන් try කරන්න. මොකද function එක fully දීලා නැහැ. function එක fully දීලා නැති ඒවා තව අපි ටිකක් practice කරොත් හොඳයි. ඒ හින්දා ඒ දෙක නැතුව එතනින් කලින් තියෙන ඒවා ටික ප්‍රැක්ටිස් කරලා ආන්සර්ස් ටික චෙක් කරගන්න. එතකොට තමයි ඔයාලට ඒක හරියට සෙට් කරගන්න පුළුවන්. මේකේ තව පොඩි පාර්ට් එකක් හරිද මේ ක්වෙස්චන් එකේ සමහරලාට තව චූටි පාර්ට් එකක් ඔය graph එක ඇඳලා ඉවර වෙලා අහන තැන් තියෙනවා. පොඩි දේවල් දෙක තුනක් අහනවා. ඒක ජෙනරල් නොලෙජ් එකෙන් අපිට කරගන්න පුළුවන්. මැත්ස් වල තියෙන ජෙනරල් නොලෙජ් එකෙන් කරගන්න පුළුවන් පාර්ට් එකක්. ඒ හින්දා මේ එහෙම පොඩි කැලලක් සමහර වෙලාවට සෙට් වෙනවා. හැම වෙලෙම නෙවෙයි. හරිද? ඔයාලා නිකන් ඒක try කරන්න. කොහොමද ලබන සතියේත් මම ඩිෆරන්ෂියේෂන් මේ graph part එක තව ඉස්සරහට questions කරලා theory ඉවරයි. හරිද? ආගන්න විනාඩියක්. ඔයාලට ඩිෆරන්ෂියේෂන් වල සම්පූර්ණයෙන්ම theory ඉවරයි දැන්. ලබන සතියේත් මම graph part එක graph sketching part එකක් තව කරනවා past paper analysis එක. ඒක කරලා ඉවර වෙලා තව මේකේ ඔයාලට A level exam එකට එන්නේ නැති points කීපයක් තියෙනවා. ඒ points දෙකේ differentiation part එකත් ඊළඟ දවසේ මම ඉවර කරනවා. ඒක කරලා differentiation part එක ඉවර කරනවා. හරිද? එහෙම කරලා applied වල ඊළඟ sessions ටිකට එනවා. අර මම කියපු පිළිවෙලට එන්නේ linear motion ඉවර කරලා relative velocity එකට ඇවිල්ලා relative acceleration ඇවිල්ලා circular motion ඇවිල්ලා අනිත් ටිකට මම එන්නේ. හරිද? ඔයාලා මේ දවස්වල මේක මග අරගන්න එපා. කලින් කරපුව අහපුව සැරයක් බලන්න. හරිද? කලින් කරපුව හැම එකක්ම අහපුව බලන්න. pass paper base වෙලා වැඩ ටික තව ටිකක් වැඩියෙන් කරන්න. ඒත් එක්කම අපේ දෙන paper එකට ready වෙන්න. ඔයාලට මම දැනට පොඩි අදහසක් දෙන්නම් paper එක ඊළඟ applied paper එක ගැන. විනාඩියක් අහගන්න. ඊළඟ paper එක ගැන පොඩි අදහසක් දෙන්නම්. ඔයාලට vectors coplanar forces වලින් ලොකු ප්‍රශ්න දෙකක්, ඒ කියන්නේ part B එකේ ලොකු ප්‍රශ්න දෙකක් මම pass papers වලින් දානවා. හරිද? 2011 ඉඳලා 24ට යනකම් තියෙන අවුරුදු 15න් හරිද? ඒ අවුරුදු 15න් දෙකක් මම දානවා ලොකු ප්‍රශ්න දෙකක්. දානවා. හරිද? මේ ඒ දෙකෙන්. ඒ vectors coplanar forces දෙකෙන් ඒ දෙක කියන්නේ part B එකෙන් ලකුණු වලින් ගත්ත ලකුණු 30ක් එතන සෙට් කරනවා. ඒ හින්දා ඒ ටික පොඩ්ඩක් ට්‍රේන් වුණොත් හොඳයි. ඒ ටික ට්‍රේන් වෙන්න. ඒකට අමතරව සාමාන්‍ය බේසික් අපි කරපුවා ටිකෙන් තමයි අනිත් ටික එන්නේ. අනිත් ඒවා හිත කරන් තියෙන මම අරක කිව්වේ මට ඔයාලගේ පාස් පේපර් ප්‍රැක්ටිස් එක තව ටිකක් හදන්න ඕනේ හින්දා. ඒ හින්දා මේ ඒ ටික ප්‍රැක්ටිස් කරලා නැත්නම් රෙඩි වෙන්න. ඒක මේ බ්‍රහස්පතින්දා සාමාන්‍ය විදියට එමුණොත් මම තියනවා උදේ මම තියලා 11:40ට මම ඒක ඉවර කරන්න. හරි අපි එන අදට ඔතන ඉවර කරමු.